All right. Hi, Patrick. This is study guide for Module 6. Chris, scientists separate the Earth into 5 distinct sections. What are they?
The atmosphere, hydrosphere, crust, mantle, and core.
Super. Atmosphere, hydrosphere, crust, mantle, and core. And Bethany, of those 5 sections, which ones can we observe directly?
The crust, the hydrosphere, and the homosphere.
Or the atmosphere. Because we can observe above the homosphere and the below the homosphere, we can observe also the heterosphere. So we can observe the atmosphere, we can observe some parts of the hydrosphere, and we can observe some parts of the crust. We cannot observe the mantle at all or the core at all directly. 4 is Jenna. Which 2 regions... Oh, and tell me if I have a different question than you do, because that could happen still. Which 2 regions of the Earth does the MOHO discontinuity separate?
My question is different.
Oh, tell me what it is.
What 2 regions of the Earth?
We'll get a video of the question, and I will see what it is also.
Oh, okay. No, that's the same.
Okay, so the MOHO, what does it separate?
It separates the crust and the mantle. The Gutenberg discontinuity separates the mantle from the outer core, and the Lehman discontinuity separates the outer core from the inner core.
Okay, does it actually ask about the layman?
Mm-hmm. Yes.
Oh, mine doesn't. Okay, good. So they're in order. That's good. So Elise, what 3 sections make up the lithosphere? Okay, what is your question?
What is the difference between the ways that igneous rock and sedimentary rock form?
Okay, go ahead.
Igneous comes from molten rock and sedimentary comes from chemical reaction.
Okay, so igneous rock forms from melted rock, molten rock. Tell me real loud about sedimentary rock, though, because it's hard to hear for Patrick.
Formed from chemical reaction.
Okay, so sedimentary rock forms when sediments are laid down by things sinking in the water or dust forming, and then heat and pressure over time, chemical reactions causes it to form into rock. So 7, hopefully, Ava, well, we've got the same thing. What is unique about the rock and the mantle?
I think it's 6.
Well, I have a different paper. Read 6.
Of the 3 types of rock discussed in the module, which type starts out as a different
As a what?
type of rock?
Okay, go ahead.
Metamorphic rock?
Metamorphic rock. So what could metamorphic rock start out as? Anyone? Dusane?
Sedimentary or igneous.
Okay, so you could take sedimentary rock or igneous rock and then
With a lot of
heat pressure time, and it changes the sedimentary or the igneous rock into metamorphic rock. So let's see. Well, Anna, would you read your question for the next one?
Oh, I have the question. I'll read it for you.
Okay, go ahead.
That's number 7?
Mm-hmm.
Yeah. What is unique about the rock in the asthenosphere?
Yep.
Is a liquid and a solid?
Okay, so that's what we're going to look at in our second experiment today, that the rock in the asthenosphere is sometimes like a liquid and sometimes like a solid. Do you know when it behaves in one way and when it behaves the other?
No.
Lily, do you remember?
With the plastic rock?
Yes.
When there's pressure on it, it's more of a liquid when you let go. Or is it when you pressure on it, it's more of a solid? And you
Yes.
let go, it's more of a liquid?
Yes, so when
Like that
there's
experiment
pressure.
When you squeezed it and it was more solid, and you let go and it was more of a liquid.
Right. So we always think that the states of matter are really affected by temperature. Because, we observe ice melting at a certain temperature, it becomes a liquid. Then we observe that if you raise the temperature up to the boiling point, that liquid will become a gas. But truly, the melting point, freezing point, boiling point are also equally affected by pressure. And so the layer of plastic rock is at a very high temperature, but also a very high pressure. And both of those factors work together to cause just slight changes in the amount of pressure on that rock to cause it to solidify. And then when that pressure is released, it becomes liquid again. So you guys will see that when we mix cornstarch and water. Like if you apply pressure, it's really, really solid. And when you release that pressure, it just like goes to goo again in your hand. And that'll help you remember. But pressure affects the state of matter just like temperature does. And the rock in the mantle will shift in that certain region when a sharp force is applied, especially. Let's see, Joseph, we're on, what question are we on? I'm on number 8.
I'm on 8.
Okay, go ahead. Read the question just in case.
What is the main thing the scientists observe in order to learn about the makeup of the Earth's interior?
What is it?
And they observe seismic waves.
Seismic waves. And do you know how the seismic waves get made?
Like earthquakes.
Earthquakes. We can learn a lot from observing the waves in earthquakes, or scientists can also make sound waves, make seismic waves travel through the earth so that they can get data at certain points or through certain areas. But it's through observing earthquakes that we even figured out that we could do that. Ryan, which is solid, the inner core or outer core? Is that your question? The outer core is solid. No, that's not right. That's totally not right. My question's different. I'm staring at a sheet that's different. The inner core is solid. The outer core is liquid, melted rock,
Because the pressure
melted metal.
Is that why the inner is solid?
It
pressure
is because both are made of iron, but the pressure on the inner core is greater than the pressure on the outer core, so that pressure causes the inner core to be a solid. Super hot, but super pressurized. The outer core has a little less pressure, very high temperature also, but it's able to be liquid. It's melted metal. It's mostly made of iron, so it's molten iron. And the inner core is mostly solid iron. In fact, I think, do we have a question about that, the makeup of the different layers? If not, our craft will have it. Max?
So plastic rock is made out of iron?
No, because it is rock, like rock. But only the inner and outer core are mostly metal. The mantle and crust are mostly rocky stuff. So why is the inner core solid? Is this the rest of your question, Ryan? Why is the inner core solid when it is hot, hotter than the outer core?
No, because
Oh, go ahead.
the other is liquid.
Tell me real loud.
It says, why is it solid when the other is liquid?
Oh, well, why is it? Why is the inner core solid?
Pressure?
Pressure, yes. When it's under high pressure, it is enough to cause it to be solid, even though the temperature is above the melting point. So you guys did all these questions about magnetic field, right?
Yes.
Okay, well, let's talk about them. Next week, we'll really go over this again. Actually, let's don't talk about them. Let's do all this stuff we need to do this week. And then next week, I'd like to spend more time on that because we're going to do the lab on that. So, yep, next week we'll talk about mountains and the core and the Earth's magnetic field and such. So, we're going to do our craft and then we'll film the end of that.